Assalamualaikum and hello everyone. My name is Fareisya Irdina, Binti Shahimi, and on behalf of my group members, I will do some introduction about our engineering economy project about cost and break-even analysis. So the product or service that we choose for this project is Chemical Health Risk Assessment (CHRA) service. Before I go more deeper about our project, I will introduce my group members who are Siow Yu Ki, Chu Mei Wing, Chang Zi Chin, Ifah, Nadhirah, and me myself, Fareisya Irdina, Binti Shahimi. Chemical health risk assessment is a systematic process designed to identify, evaluate, and control health risks associated with the use of hazardous chemical in the workplace. So, CHRA are responsible in hazard identification, exposure assessment, documenting and reporting, and also provide training and awareness to the workers. So, in this project, we choose scenario one, which is there is a demand on our services, where in 2034 there are change of regulatory that acts require all the manufacturing facilities to handle hazard. So this will create a demand on our service by other manufacturing facilities since these services are needed to them. So the management teams will compare these services from other provider and they will choose the best one to conduct the assessment for their facilities. So ongoing assessment may be needed as regulation change, sustaining the demand for CHRA services.
For demands and benefits, regarding to scenario 1, demand is very important. This assessment very high demand as it is a mandatory requirement under the occupational safety and health for every industries that involve chemical usage in their process. Also, it is very high demand because of three main points. First, Environmental Quality Amendment Act 2024 related to the fine given if there was environmental violations. Second, Act and regulation involved in the Occupational Safety and Health Act 2022 on the standard exposure of chemical and the classification. And the last one, CHRA need to renew at least once assessment per year or usually every 5 years. As no workplace remains the same, therefore update the CHRA if necessary. For example, if changes occur such as new machinery or equipment. Then, for competitors, there's a lot of training providers certified by Department of Occupational Safety and Health to do the chemical health risk assessment.
The fixed costs for our service are 3,275 ringgit per month, which include rental, utilities, and salary for 2 workers as we are just a startup company. And the variable costs are 106.58 ringgit per unit, which include mobilization and consultation fee, regulation plus packaging fees, printing costs, and materials which are pens and papers. The equation for our cost structure is price equals to 250 ringgit minus 0.19D. And this is our spreadsheet solution. The price per unit P equals to A minus BD, where A equals to the constant of highest selling price, which is 250, B equals to amount by which demand increases for each unit decrease in P, which is 0.19. These values are developed by referring to the current trend in the market. Total revenue, column C equals to demand multiplied with price. Total expenses, column D equals to fixed cost plus variable cost multiplied with demand. And the profit, column E equals to total revenue minus with total expenses.
So after Excel calculation, we can generate a graphical displays of the cash flow for a range of demand value. So we got a solid curve, which is the total revenue, and we got a dashed straight line below the curve is the total expenses, and also lastly we got a dotted line at the below is the profit earned based on demand. So now we will move on to see how to calculate the optimal value of demand that maximize profit. So by using formula 1, we calculate the optimal demand that produce maximum profit by substituting the AB value that we decided just now. And the calculated optimum demand will be 377 unit per month. Then we will use this demand value to calculate the maximum profit by using formula 2. And then the value will be 23,789 ringgit and 83 cents per month. And then the sign of the second derivative of the profit function is negative, so we can make sure that we have maximized our profit. And refer to the graph below, the yellow line shown in the middle of the total revenue curve and the total expenses line is where the maximum profit is located at. And also the blue cross point located at the highest point of the profit curve indicates the maximum profit as well.
Here, I will dive into the break-even analysis for finding break-even points 1 and points 2. Based on this graph, we could see that there are 2 intersection points between total revenue lines and the total expenses lines. These 2 points are known as break-even points 1 and points 2. The break-even happens when the total revenue is equal to total cost. To find those points, we could use the quadratic formula, which is written as negative b plus or minus square root b squared minus 4ac over 2a. To use this formula, we need the a, b, and c value, which we could obtain from the quadratic equation that we formed from the total revenue and the total cost equations. This equation is negative 0.19d squared plus 143.42d minus 3275 equal to 0. With the a, b, and c value, we could substitute those values into the quadratic formula, and finally we could find the break-even point 1 is 24 units and the break-even point 2 is 731 units.